So this is the second day that we're spending on this section, multiplying polynomials. And it's really just distributive property, right? So if we take a look at number 2, for example, all you have to do is pretend that there's only one term out here instead of 2, right? So I'm just going to cover up 1. So I'm going to distribute x times x, and I'm going to get x squared. X times 4, I'm going to get 4x. And then I'm going to move this over and distribute the 7. Actually, I'm just going to get this out of the way. If you have different colored pens, it'd be a good idea to use different colored pens. So x times x, that is x squared. X times 4, that is a positive 4x. Okay, is anybody confused with that? X times 4 is 4x? No. I mean, it's like having a 1x times 4, and 1 times 4 is 4, and the x just comes down on the answer. And then I want to go positive 7 times x. So I've already distributed the x. Now I'm going to distribute the 7. So it's positive 7 times x is positive 7x, and then positive 7 times 4 is positive 28. Now out of those 4 terms, we're going to combine the middle ones, right? After distributing, you got to combine like terms. So we have 4x and 7x, and when I combine those, it's like 4 plus 7. That's simply 11 of those x's. And of course, I bring down the x squared, bring down a positive sign because that is positive 11. Bring down the plus 28. That's it. We're done. And it is in standard form, so we're good. Let's jump to another similar. So number 7, it's a little bit more fun because it has coefficients in front of the variable. So once again, we're going to distribute. I might as well do this one the other method. Instead of using squiggly underlines to combine like terms, I'm actually going to line them up. So 6a times 7a. 6 times 7 is what? 42. A times a is what? A squared. So our first term is 42a squared. So I like to draw arrows and then do the math. So I already distributed 6a to the 7a. Now 6a to the negative 4. What's 6a times negative 4? That is negative 24a. There you go. And now we're going to, since we already distributed the 6a, now we're going to distribute the minus 3. Right? So it's like if I had that blocked, and now that I've already distributed the 6a to both terms, now I'm going to move this over and block that and distribute the minus 3. So minus 3 times 7a, that's what? Negative 21a. Now you could write it right here, negative 21a, or the other option was to write your next term underneath the other term that you're going to combine. So instead of writing negative 21a on the side, I'm going to write negative 21a right below the negative 24a. And then I'm going to distribute negative 3 times negative 4. That is a positive 12. So you could set it up like this, right on top of each other, so it'll be more like linear combinations. So the first part of your answer is 42a squared, and then minus 24 and a minus 21. If you owe $24 and you owe $21, you're going to owe 45 of those dollars, but in this case, A values, not dollars. And then the plus 12 comes down, and that is it. That is your answer. Any questions? Now, I actually prefer, I like writing everything horizontally, side to side, and then I use different symbols like squiggly lines or circles or boxes to combine like terms. You don't have to write it like that. You could set it up right on top of each other. That way you don't have to use any symbols to combine. You just combine straight down. Okay, so it's totally up to you. Now, when we have a binomial times a trinomial, that's where it gets more fun, or it gets honestly, it gets ridiculous with the trinomial times a trinomial. So let's check out number 14. A binomial times a trinomial, easy. You're just going to distribute 3d times 2d squared. So what's 3 times 2? 6. Okay? And what is d times d squared? D to the third. So our first answer is 6d to the third. And then let's distribute 3d times 5d. What's 3 times 5? 15, and let's put a plus sign since it's positive 15. And then what is d times d? D squared. So our second term is 15d squared. Now for our third term, take that 3d and distribute it over here times negative 2. So what's 3d times negative 2? Negative 6d. Okay. Now do you guys want to write it horizontally or do you want to line them up? Line them up? I guess since it's a trinomial, I'm going to line it up so it'll be easier to see. And maybe on the next one I'll do the horizontal one. So let's line them up here. Let's go positive 3 times 2d. What's 3 times 2d? Actually, 2d squared. That becomes 6d squared, right? Now, where am I going to line that up? Underneath what? Underneath the 15d squared. That's right. So let's put that positive 6d squared right below the positive 15d squared. And now let me distribute 3 times 5d. What's 3 times 5d? 15d, and where are we going to put that? Right below the minus 6d. So we're going to put positive 15d right below the minus 6d. And last but not least, 3 times negative 2. That's just negative 6. And since I lined them up on top of each other, I could just draw a line there and pretend that we're doing like linear combinations, and our answer will be 6d to the third plus $15 plus $6, that's $21. But in this case, we're not talking about dollars, we're talking about d squared values. And again, notice that the d squares did not change. I didn't add 2 plus 2 and get d to the fourth. You don't do that only when you multiply. That's when exponents change. Right here, exponents do not change because we're simply adding. And the next term, negative 6d, you owe somebody $6. You have $15. You're going to have $9 left over. And then the minus 6 comes down. There's nothing to combine it with. This is your answer. If I were to ask you to classify it, first and last name, based on degree and number of terms, what would it be? If you look at the wall right there. Cubic polynomial. Cubic polynomial. Cubic because the degree is 3. Polynomial because there's many terms. So, which other one? 15? 15 and then 17? Dang, 17. Yeah, 15 then 17. So 15, let's distribute. Different colored pens. 3q times 9q. This reminds me of a joke. What's 5q plus 5q? What's 5q plus 5q? You're welcome. It's not. 10q? Thank you. 5? Forget it. 5q plus 5q? Yeah. 10q. And I say you're welcome. Oh. Yeah. Thank you. Yeah. All right. Okay. That was just. No, you guys didn't like it at all. That was horrible. I will never say that joke again. 3q times 9q squared. What's 3 times 9? 27. And q times q squared. Q to the third. Remember, that's like a q to the 1 times q to the second. You have to add those exponents, q to the third. Okay, so now 3q times negative 12q. Negative 36q squared. And then 3q times 4. What's 3q times 4? That is positive 12q. And now let me distribute the positive 2 times 9q squared. What's 2 times 9q squared? Positive 2 times 9 is 18, and q squared is just added on to the 18 because there's no other q to multiply it with. So 2 times negative 12q, what's that? Negative 24q. And the last one, 2 times 4, what's that? 8. Okay, so notice right here, I did not line them up one on top of the other. So right here, I really do need to use different symbols to show how I'm going to combine the terms that look alike. So I am going to go with the, well, first of all, 27 q to the third. There is no other term that has a cube or a third power. So I just bring that down as the first part of my standard form answer. And then I move on to combining this negative 36q squared, I put that in a box. I want to combine that with the positive 18q squared. So if I owe somebody 36 of those q squares, but I have 18 of those q squares, what do I end up with?
18q squared.
Positive or negative?
Negative.
Negative. So you owe 18 of those q squares. Okay, and then I'll use a different symbol, a squiggly underline here. How about a positive 12q and a negative 24q?
Negative 12q.
That's going to be a negative 12q. That's right. And what else is there to combine? Nothing. There's just this plus 8 left over, so I bring that down, plus 8. And there's my final answer. 27q to the third minus 18q squared minus 12q plus 8. That would be, again, a cubic polynomial if I were to classify it based on the degree and number of terms. Now, when you have a trinomial times a trinomial, dang, that honestly is very time consuming. If I give you one of these on Fridays, or actually Thursday's test, it'll only be one because it takes so long. And it will be selected from the homework. You don't know which one it's going to be, so you might as well be able to do all of them. So on this one, I am going to line them up vertically. Okay, so check it out. Let's go 3y squared times 3y squared. What do I get? 9y to the fourth. That's right. And then how about 3y squared times negative 4y? Negative 12y to the third. And then 3y squared times negative 5. Negative 15y squared. Okay, great. We've distributed one term. This is going to be very long. Let's distribute the next term. 2y times 3y squared. 6y to the third. Now notice, I'm going to write that 6y to the third, that positive 6y to the third, I'm going to write it right below the other y to the third term. That way I could combine them. And then I want to distribute 2y times negative 4y. What do I get? Negative 8y squared. And I want to put that negative 8y squared right below the other y squared term. That way I could just combine them. And then last but not least, 2y times negative 5. What do I get? Negative 10y. Are we done? No, we still need to distribute that last term, the 2. So let me go with green, even though green doesn't show up that great. 2 times 3y squared. 6y squared. And let me write that 6y squared right below the other y squared terms. And then 2 times negative 4y, what's that? Negative 8y. Notice that I wrote it right below the other y term. And last but not least, 2 times negative 5, that's negative 10. Dang. This is going to be long and nasty. So the answer, the 9y to the fourth, that just comes down. Let me write it over here. 9y to the fourth, that's the first part of my answer. Now the next part of my answer is negative 12 plus 6. And what do we get? Negative 12 plus 6. Negative 6, and we still have those y to the thirds. And now this next one, we have to combine all these three y squared values. So if I owe 15, it's probably easier to combine these first. You owe 8. Yeah, you owe 8, you have 6, you're going to owe 2, and then you owe 15, you owe 17 altogether. So negative 17y squared. And then the y's, how about if I combine these guys? What do I get? Negative 18y. And last but not least, minus 10 is the only value left over right here. So you bring that down. And this is our ginormous answer for that time-consuming problem number 20. So, work on the rest of these. I'm telling you, questions from the quiz or test this Thursday are coming straight from the worksheets we've had last week and this week.